Now we are going to discuss about some questions given in our exercise from the unit gravitation. To solve the problems in this unit, we should know certain equations. Among that, first one is the gravitational force of attraction between any two body in the universe. That equation is F is equal to G M by D square. Here G is the gravitational constant. That value you know, M, mass of one of the body, and this mass is another body, or second body, and its mass. D is the distance between the centers of the two bodies. And then we should know about that this force of attraction is also equal to weight. So F is equal to mg under O, and W is also equal to mg. Then you should know about acceleration due to gravity. Its value g is equal to how much it will be? 9.8 meter per second square. Then we want to know about what is free fall. Then mass and weight. What is the difference between these two? With these all we can solve the problems and questions from exercise. Among that, up to the question number 6 we did in our previous class. Now question number 7. What is the importance of universal law of gravitation? What is the importance of universal law of gravitation? What is its importance? Can you remember it? What is its importance? The universal law of gravitation gives or help us to measure force between any two bodies in the universe. That is F is equal to Gm by D square, means it is the force between any two bodies in the universe. So universal law of gravitation help us to find the force between any two bodies in the universe. Now from this we got that idea. Now question number 8. What is the acceleration of free fall? What is the acceleration of free fall? What is actually free fall? Free fall means when a body falls under the gravitational force alone. When a body falls under gravitational force alone, then we can say that body is under free fall. Then its acceleration is how much? It is 9.8 meter per second square. When a body is under free fall, its acceleration is how much? It is 9.8 meter per second square. It is the acceleration of a body falling without any other force, only due to gravitational force. Now we can go to the next question, which is that one. That question is question number 9th one. What do we call the gravitational force between the earth and an object? Question number 9th one. What do we call the gravitational force between the earth and an object? The gravitational force between an object and the earth is actually, it is the force of gravity. It is the force of gravity. Otherwise we can say it is also equal to weight of the body. Gravitational force between a body and earth is equal to force of gravity or weight of the body. Force of gravity or weight of the body. That is the answer for this question number 9. Then next one is question number 10. Question number 10. Amit buys a few grams of gold at the poles as per the instructions of one of his friends. He hands over the same when he meet him at the equator. Will the friend agree with the weight of the gold bought? If not, why? See, Amit bought the gold at the poles. And now he is handing over this gold where he is handing over equator. Now we want to know he will agree with the weight what he bought by Amit. He does not agree because we know weight of the body is actually what is a gravitational force. W is equal to mg. We know the value of g at the pole is a little bit more than that at the equator. So when we take the weight of the ornaments or gold at the equator, that means there also its weight W is equal to mg, but he bought the gold at the poles here. See, at the equator the value of g is less than, that of the poles. So the weight of the gold is a little bit less than where at the equator than that of the poles. So here the weight of the body is more, that means weight of the gold here more, here the weight becomes less. Here the weight becomes less. Why this weight becomes lesser? Here the value of g is lesser. So his friend does not agree with Amit. Now see, next question number 11th on. Why does a sheet of paper fall slower than that one is crumbled into a ball? That means after taking two pieces of paper of the same size, if one paper is crumbled and other one is flattened, then we drop both pieces from the same height. The flattened paper comes a little later than the crumbled paper. What is the reason for this means? When the paper crumbled, its density increase. When the paper crumbled, its size decrease. When its size decrease, its density increase. But so the resistance offered by air or the friction offered by air decrease. But for the case of a piece of paper which is flat, there the resistance offered to it due to air or friction due to air is more, so that one is come later. Why the flattened paper comes later means when it is dropped from a certain height, the air resistance acting on it is more, or friction of air in it is more than that one of the crumbled paper. So crumbled paper reaches the ground at first, but the flattened paper take a little more time. Now we are going to next question, that is question number 12. See, gravitational force on the surface of the moon is 1/6 as strong as gravitational force on the earth. That means the gravitational force on moon is 1/6 times as strong as gravitational force of the earth. What is the weight in Newton of a 10 kilogram object on the moon and on the earth? That means a 10 kilogram object. That means mass of the object is 10 kilogram. Then its weight we want to find where on the moon and also on the surface of the earth. We know force, that means exerted by moon is 1 by 6 times as that of the earth. That means the gravitational force of the moon is 1 by 6 times as that of the earth. Here, force exerted by the earth, W is equal to, force is actually equal to weight. W is equal to 1 mg. That is equal to m10 into g 9.8. That is equal to 90. That is equal to how much? 98 Newton. How much is it? 98 Newton is the weight of the object on the surface of the earth. Weight of the object on the surface of the earth is W is equal to mg. That is equal to 98 Newton. How much it is? 98 Newton. Then weight of the object on the surface of moon, that is equal to 1 by 6 times the weight that is on the surface of the earth. That means 1 by 6 into 98. That means 1 into 98 divided by 6. That is 98 divided by 6. 1 times 6. Remaining 3, 38. 6 times 36. 2, 3. Again, if we repeat it, we get 3. That is weight of the object on the surface of the moon is equal to 16.33 Newton. 16.33 Newton is the weight of the object on the surface of the moon, but its weight on the surface of the earth is how much? 98 Newton. How much is it? 98 Newton. Now, I hope you got idea about how to calculate weight of the given object on the surface of the earth and also on the surface of the moon. Now we can go to the next question, question number 13 on. See, a body is thrown vertically upwards with a velocity of 49 meters per second. That means body is thrown upwards with a velocity of 49 meters per second. Calculate the maximum height to which it rises, and then the total time it takes to return to the surface of the earth. That means we want to calculate two things. First of all, we want to calculate the maximum height to which it rises. That means maximum height to which it rises is the displacement that we want to find out. We know that the object is thrown with a velocity of 49 meters per second. Object is going upwards, so the acceleration is equal to, or that is also equal to g minus 9.8 meter per second square. When the object is reaching at the top of the, or at the top position, its velocity, that is final velocity, becomes 0. Its final velocity, then it will become 0. So we know u, that is initial velocity, acceleration, and final velocity. So we can find out displacement. That means their height. We know what is 2a s equal to v square minus u square. Here a is g, that is 2 into minus 9.8 into s equal to final velocity 0 minus u, that is 49 square. So from this s equal to 49 square divided by this 49 square is actually how much? It is equal to 49 into 49 divided by, here one minus this 2 into 9.8. 2 into 9.8, here also without minus. Minus by minus it become plus. Now see, here on decimal point, to shift this decimal point we can put odd and upside. Now this is 98. Now this 98 and 49 we can cut, we get 2. So this 49 into 10 divided by 4. That means again we can cancel with the 2, or otherwise this 490 divided by, here how much it will come? 490 divided by, here 2 into 2 4, minus by minus it will become plus. So S is equal to 490 divided by 4. That means 4, how many to 1, 4, then 9, 2 times 8, then balance on and 0. That is equal to again 2 times, that is 8, then 2, again 20, how many times 5? That means 5 times 4, 20. So the displacement S is equal to how much will come? That means it will go up to a height of 122.5 meter. That is a height that the stone attained is 122.5 meter. That is the answer for the stone that is going up to a height. Now, what are the things we want to find out? The second things we want to find out, the total time it takes to return to the surface of the earth. Total time it takes to return to the surface of the earth. That is, we want to find out time also. If we use the relation V is equal to U plus A T, here V final velocity is 0 and U initial velocity it is 49 plus A it is minus 9.8 into T. This minus T we can bring to this side, then it will become plus, that means 9.8 T is equal to 49. So T is equal to 49 divided by 9.8. That means again here is on decimal place. Okay, see T is equal to 49 by 9.8. See this decimal we can shift by giving on 10 to upside. So this become 49 into 10 by how much? 98. Now in 98 to 49 how many times? 2 times. So this T is equal to 10 by 2. T is equal to 10 by 2 is equal to how much? 5 seconds. That means the time it took to reach at the top is how much? 5 seconds. Here the question is the total time it takes to return to the surface of the earth. That means the ball takes 5 seconds to go up. Then from top to bottom, from the top to the ground, it again takes 5 seconds. So the total time taken is 10 seconds. So the total time taken is how much? 5 plus 5, that is 10 seconds is the total time taken. Now, question number 14. A stone is released from the top of a tower of height 19.6 feet. That is the height of the tower. That is actually this 19.6 meter. A stone is released from the top of a tower of height 19.6 meter. Calculates its final velocity just before touching the ground. We want to find out the final velocity just before it is touching the ground. You see, its initial velocity u is equal to, we know, 0. That means when the stone were dropped, it was at rest. So its initial velocity is 0. Then g is a or g is equal to how much? It is 9.8 meter per second square. Then we want to find out at what velocity that will come to the ground. We know b square is equal to u square plus 2as. Here v is the final velocity. So v square is equal to u, initial velocity is 0, plus 2 into a is here g, that is 9.8 into s, that is also 19.6 here given. From this v square is equal to this 0, no need to add. So 2 into 9.8 is 19.6 into again 19.6. So we can take a square root from both sides to get v. V is equal to a root of 19.6 into 19.6. So it will get us 19.6 meter per second. This is the velocity with which the body strikes the ground. That means root of 19.6 here. 19.6 is 2 times, so we can take 1 from this. So we get 19.6 meter per second. At this velocity, the stone strikes the ground. See once again, here given height, it is also equal to displacement, that is 19.6. Here u, that is initially the stone were at rest, so it is 0. A is equal to g, acceleration due to gravity. Here it is 9.8 meter. We can use this relation. V square is equal to u square plus 2s. By substituting and simplifying, we will get to the value of p as 19.6 meter per second square. Now, question number 51. A stone is thrown vertically upward with an initial velocity of 40 meter per second square. Taking g 10 meter per second square, find the maximum height reached by the stone. What is the net displacement and the total distance covered by the stone? See, a stone is thrown vertically upward with an initial velocity of 40 meter per second. That is u is equal to 40 meter per second. Taking g is equal to 10 meter per second. G here given as 10 meter per second square. Then find the maximum height reached by the stone. What is the maximum displacement? That is the height. Find the maximum height reached by the stone. What is the net displacement and the total distance covered by the stone? What is the net displacement and total distance covered by the stone? See, at the maximum height, that means we can take s equal to h. Here you see, at the maximum height, its final velocity v becomes 0. At the maximum height, final velocity v becomes 0. So, by using the relation, we can find out which relation v square is equal to u square plus 2as. Here, at the maximum height, how much it is? 0 square is equal to u square square 40 square plus 2 into A. The stone is moving up, so it is a minus 10 into S. This minus 10 we can bring to this side, so 2 into 10, 20 S equal to 40 square. That is 40 into 40. So S is equal to, that means 40 into 40 by 20. We can cancel 2. That means the maximum height in the reaches is 80 meter. That means maximum height that stone reached is 80 meter. Now the first question answer is this one. Now another question is what is the net displacement and the total distance covered by the stone? Net displacement means the stone is thrown from the ground and it goes up to a certain height, again returns to the same position. So the net displacement is net displacement equal to 0. Because there is no change in its position, it goes up to this height of 80 meter, then again it returns to the same position, so the net displacement is 0. But the total distance, see, when it is going up, it moves to 80 meter. When it comes down, again it travels 80 meter. So the total distance traveled is 160 meter. Total distance traveled is how much? 160 meter is the total distance traveled by the stone. Now we can go to another question. Question number 16. Calculate the force of gravitation between the earth and the sun, given that the mass of the earth is given as 6 into 10 raised to 24. Into 10 raised to 24 kilogram, and that of sun is 2 into 10 raised to 30 kilogram. The average distance between the two is, that means D is equal to 1.5 into 10 raised to 11 meter. These are the data given. Here question is this, calculate the force of gravitation between the earth and the sun, given that the mass of the earth is 6 into 10 raised to 24 kilogram and that of the sun is 2 into 10 raised to 30 kilogram. The average distance between the two is 1.5 into 10 raised to 11 meter. Now we know how to calculate gravitational force. That is F is equal to G, capital mass of the sun, small m here mass of the earth, and D is the distance between these two. So G is equal to 6.67, that we can take as approximately 6.7 into 10 raised to minus 11, and mass of the sun is given as how much? 2 into 10 raised to 30 into mass of the earth is given how much? 6 into 10 raised to 24. These are the values of G, M and smaller. Then the distance between these two is given as 1.5 into 10 raised to 11. See here, the whole square, d square is here given. Here we can cancel the power with a minus, that is 6.7 into 2 into 6 into, see, 10 raised to 30, 10 to the power 30 into 10 to the power 24, that means 10 to the power 54. From 54, when we subtract this 11, we get as 10 to the power 43. That means 30 plus 24, 54. Because we know what is a raised to m the whole into a raised to n is equal to a raised to m plus n. That relation is using. Then this minus n, that is m minus n. Here 11, so 54 minus n, 11 is equal to 43. Here this will come as 1.5 into 1.5 into 10 to the power 11, the whole raised to 2, that is 10 raised to 22. This 22 we can subtract this 43, then how much it will come? That is, this all quantities we can multiply, that is 6.7 into 2 into 6 is 12 into 10 raised to. From this 43, when we subtract 22, we get it 21. Here 1.5 into 1.5, that is a 225. Here 2 decimal place 2.25. These two when multiplied and divide with this, then we get the value as it is equal to 3.57 into 10 raised to 22 Newton. That means these two multiply and divide with this and putting this value, we get how much? 3.57 into 10 raised to 22 Newton is the force between the earth and the sun. Force between the earth and the sun is this much. How much it will be? 6.4, that is 3.57 into 10 raised to 22 Newton. It is a very large force. Now we can move to the next question. See question number 17. A stone is allowed to fall from the top of a tower 100 meter high, and at the same time another stone is projected vertically upwards from the ground with a velocity of 25 meter per second. Calculate when and where the two stones will meet. That is a tower. Its height is 100 meter. From the top, a stone is dropping. That is, one stone is dropping from its top. And at the same time, another stone thrown upwards from the ground with a velocity of 25 meter per second. We want to find out where these two will meet. That means this stone is coming downward and this stone is going up. Where these two meet. Suppose these two will meet at this point. Suppose this P. Now see, this distance is total distance is 100, and here the distance is how much? This distance is 100 minus. Let this height is h. This height is 100 minus h. We want to find out when these two stones will meet. That means at which point these two will meet. That we want to find out. Once again the question. A stone is allowed to fall from the top of a tower of 100 meter high, and at the same time another stone is projected vertically upwards from the ground with a velocity of 25 meter per second. Calculate when and where the two stones will meet. Okay. Then these two things we want to find out at what time these two will meet and which height these two will meet. See, we can take this distance. Displacement, we know the relation is equal to ut plus half a t square. From that, yes, 100 minus h is equal to this relation. S is equal to ut plus half a t square. So 100 minus h is equal to u. Initial velocity is 0 into t plus half. Here a is 9.8 into t square. Once again, 100 minus h is equal to, this step is we can remove, and by dividing this 2 we get 4.9 t square. This we can take as relation 1. Now the stone, this time, that means when the stone reaches at the point t, the time taken is t. And at the same time, this stone is moving upward. And from this relation, see here, initial velocity s means here, we know the relation s is equal to ut plus half a t square. So here s equal to h, u means here 25 into t plus this stone is moving upward. So half into minus 9.8 into t square. See, h is equal to 25. That means ut, u is here 25. Initial velocity is 25 meter because it is thrown upward. And time t, where the two bodies meeting, plus a half into minus 9.8 t square. Again, h is equal to 25 t. This plus into this minus become minus this 2. When 9.8 is divided with the 2, we get what is 4.9 t square. This we can take as relation 2. Now adding this relation 1 and 2. Adding the relation 1 and 2, what we get this, when we add the relation 1 and 2, 100 minus h plus h is equal to, here 4.9 t square plus 25t minus 4.9 t square. See, this minus h plus h we can cancel. This 4.9 t square and this minus 4.9 t square also cancel. Then what will get 100 is equal to 100 is equal to how much? 25t. So t is equal to 4 seconds. T is equal to 4 seconds. That means after the projection of 4th second, these two will meet. That means the stone from the top of the tower and the stone thrown vertically upwards, these two will meet in a time of 4 seconds. That means they will meet at the time 4th second. Okay, this is the time at which they meet. Now, the distance that they travel, that also we want to find out. That is, from the first relation we got what is, we want to find out that is when this stone is dropped, here it reaching, that is time taken is 4 seconds. So, distance s is equal to u t plus half a t square. Here s is equal to u initial velocity is 0. So this relation we can remove. Then what we get? A half into a 9.8 into t is how much? 4 square. So s is equal this 200, that is 4.9. 4.9 into 4 square, 16. 4.9 into 16, how much it will be? That is the stone reached, that means these two are meeting at a time of 4 seconds. So S is equal to 4.9 into 16. Balance 5. 6 times 4 is 24 plus 29. 9 times 54, balance 5. 6 times 4, 24 plus 5, 29. 2. That is equal to 78 S is equal to 78.4 meter. Then the other height, that means from here to this point, from the other height that we can find out from, subtract the 78.4 from 100. So this height is that is from ground to the point peak is 78.4. We want to subtract from 100. That means 100 minus 78.4. How much it will be? 1 is taken. 1 6. Here 9. 1. And here 9 2. That is equal to 21.6 meter. The second distance is 21.6 meter. This is the two heights. That means the stone dropped to a height of how much? 17.4, and another one is 21.